All right, another example of kind of analyzing a hyperbola, graphing from the equation, whatever. You're given an equation, just find out all the information you can about this thing. And so our example here is, my apologies, it's going to be y squared over 4 minus x squared. Well, here, a nice way to start whenever you look at these is you say, all right, y cannot be 0 because you can't not have a first term, otherwise you'll have a parabola of some flavor. And what is y equals to 0? Well, y equals to 0 is this x-axis, and my graph can never touch that. So I know that necessarily I have a vertical hyperbola, one that opens up and down, and we haven't done one of these yet. So it never crosses the x-axis because the x-axis is y equals to 0. So let's take this thing, let's identify, let's put it into the format for the equation. Y squared over b squared, well, b squared, so 4 squared can be written as 2 squared minus x squared over a squared equals to 1. Well, above it, it's x squared. There is no denominator. Well, yeah, there's always a denominator. It's always over 1. And what squared is 1? Well, 1 squared is 1. So a is 1. So we've got a is equal to 1, and we've got b is equal to 2. We draw a quick triangle here with a is 1 and b is 2 here. So a is 1 and b is 2. And that allows us to find the distance from the center to the foci as c. So Pythagorean theorem here, c squared is equal to the square root, c is equal to the square root of 1 squared plus 2 squared. And if that's, don't hesitate to go back a step and don't skip the algebra and write out c squared equals a squared plus b squared and just do the math. And you'll see that c is equal to plus or minus the square root of root 5. And we know that it's a distance, so we're going to say, hey, c is equal to root 5, which we're going to approximate as, I don't know, 2.2, I think. Sounds reasonable. Don't hold it against me if I'm off a little bit. I don't have a calculator in front of me. So, ready, steady, and go. Yep, 2.2 is a good approximation anyway. We know A, we know B, we know C. We can draw ourselves, and from here we can graph our hyperbola. So let's do it. Let's do it right down here. Let's see. Give yourself an x and y axis, and make them fairly large. 1, 1, 1 in the x direction. Do a little better than that. And then 1, 2, 3 in the y direction. Why not? 1, 2, and 3. That should give us plenty of room. So now our b value. B is go vertical 2 from our center at the origin, because again, we're in the formula. It's in the format. We know that our center is 0, 0. And so you're symmetric. You're going to have a vertex above and below. And these are vertices, because we know this thing opens vertically. But even if we didn't know that, we kind of actually have to figure that out. I lied. And now the a direction is 1, so the x direction we go 1 in either direction from the origin. Now let's plot our foci. And so 2.2 is just a hair above our vertex here at 2.2, and then we'll go down as well. Well, here's good enough. We can draw our box from this to connect our a and b values. And then once we have our box, we'll go ahead and draw our asymptotes. And once we have our asymptotes, we can draw a pretty darn accurate hyperbola. And so asymptotes, vertices, foci, we know that it opens upwards, which we had already figured out, but this kind of confirmed it. But we did need to know that, otherwise we would have put the foci on the wrong axis and we would have had it open up the wrong way. So there's our hyperbola graph. And now it just becomes a game of finding all of the things. And so let's do asymptotes here. Our slope for, and again, I'm going to do L1 as the vertical one, and L2 you're going to see is similar. So L2. So for the slope for L1, we've got rise. How much do you rise? Well, we rise in the b direction, so we rise 2 over we run in the x direction, so we run 1. And so the slope is 2. And if you do the math for the downward asymptote, you'll see that L2 is equal to, has a slope of -2. So your two equations for your asymptotes, L1 is going to be y equals 2x, and L2 is going to be y equals negative 2x. And again, we're using the fact that any line that goes through the origin is completely defined by its y equals m times x by its slope. That's how we came up with these two asymptotes. So the last thing to do here would be just to list it all out. Our center we know is at 0, 0. Our vertices are going to be at 0, 2 and 0, negative 2. And then our foci, and again, exact values here, 0, root 5, and then 0, negative root 5. And then our transverse axis, let's think this one through and not stumble like the last example. Well, the transverse axis is the vertical axis here. So the equation for the vertical y-axis is that your x value is always fixed, x is equal to 0. And then our asymptotes, L1, the kind of uphill one is what I've been calling it, y is equal to 2x, and L2, the downhill one, y is equal to negative 2x. And we've got all of the possible things we could possibly ask about this hyperbola found.